Now that you've built your unit circle, what we're going to do is talk about some relationships between the angles in the first quadrant that we learned about yesterday and the rest of the unit circle. So you'll see here, I wrote down two things that you want to add to your notes. We'll give a couple examples to show. But the first one there is that angles with the same denominator have the same reference angle. So if we look at an example, maybe we're talking about the angle 7 pi over 6. Maybe that's the value of our theta. Well, when we go to sketch that, what we'll notice is that the denominator here is 6, so the reference angle is going to be pi over 6, which is, of course, an angle in our first quadrant. Maybe another example would be if theta equals, let's see, 11 pi over 3. Well, since 3 is the denominator, then baby theta is going to relate back to pi over 3. And again, even though those angles are outside of the first quadrant, I can just look at that denominator to be able to tell that. The other thing is if they have the same reference angle, then you should also notice on your paper plate that they have the same ordered pair if we ignore the signs. Okay, so obviously in other quadrants, the ordered pairs get negative signs on some of the coordinates, but the basis of the ordered pair is the same. So for example, if theta is 3 pi over 4, well, baby theta would be pi over 4. And we know in the first quadrant that the ordered pair here is root 2 over 2, comma root 2 over 2. And that means that this ordered pair is also root 2 over 2, comma root 2 over 2, but because it is in the second quadrant, the x value is negative. So if we ignore that one negative sign, they have identical ordered pairs. Now, there's one other thing before we start finding values that we're going to talk about, and that's this memory aid for signs. So again, if you don't want to have to memorize the entire unit circle, what we can do is just find a way to learn where specific values are positive, negative, and so on. And what we're going to talk about, the phrasing for this, the way to remember it, is all students take calculus. Whether that be true or not, we're going to go with it. Another way to word this is all students think critically. You pick the phrasing that works for you. But basically how this works is we start in the first quadrant, and what it means is we put all here. And I'm going to put a positive sign. All positive means every single trig value that they ask us to find, it doesn't matter, all of the values are going to be positive because the x's and the y's are all positive in the first quadrant. When we go over to the second quadrant, the S for students stands for sign. And that means that the sign values are positive because the y value is positive in the second quadrant, whereas the x is negative. So we just have to remember that sign. And then, of course, the reciprocal function cosecant would also be positive. The T in take stands for tangent. So in the third quadrant, tangent is the only positive, and cotangent, of course, because both coordinates would be negative. So when you do division for tangent and cotangent, the negatives cancel. And then the C, our last remaining original trig function, is cosine. Cosine is positive in the fourth quadrant because the x coordinate is positive, whereas the y coordinate is negative. And of course, if cosine is positive, that also means secant is. So what we're going to do here, and we'll get some steps here in a moment, but we're going to kind of merge these two ideas together. We're going to use those angles from the first quadrant to get the ordered pair, and then we'll use the all students take calculus concept to determine what has to change in that ordered pair, if anything needs to become negative or if everything's positive and so on. So let's take a look down here. I've written out some steps, and then we'll do a couple examples to show what I'm talking about for each. So first and foremost, I would start with a sketch of the angle just so you have an idea of what you're looking at. And really, honestly, steps 1 and 2, you could do those in either order because you might determine the quadrant to help you build the sketch. Step 3 is going to be to determine the reference angle. Again, you could almost do that right out the gate because looking at the line above, the reference angle is built off of that denominator. Step 4, we're going to determine the sign, and that stems back from all students take calculus, if you want to rewrite it down here. And then once you have that, you're going to know your ordered pair from the reference angle. You're going to know the sign of whatever piece of it or pieces you need from All Students Take Calculus. Then you'll finally just state the answer. So again, you might find a different process that works for you. Your alternative to this is to, of course, just memorize the entire unit circle, not the strategy that I personally would take, but that is an option. You also could resketch the unit circle. You wouldn't have to know everything in your head, but you could just kind of lay it out on paper. But let's try a couple using these steps and see how that goes. So for example 1, we want to start by sketching 7 pi over 6. So I'll do that down here. If we get a quick sketch going on 7 pi over 6, so if we pi over 6 would mean that the top here would be 3 pi over 6. Obviously 0 is over here. This would be 6 pi over 6. And then 7, my brain was thinking ahead there, 7 is going to be 1 past that, right? Because 6 pi over 6 is 1 pi. So we're looking at this angle. That is our theta. So the reference angle for that angle is going to be pi over 6. And of course, we fell in quadrant 3, where all students take calculus, tangent is positive. So we are being asked to find cosine. So we need the x value. Cosine corresponds to the x, right? And the ordered pair for pi over 6, perhaps you're using your left-hand trick. Hold down your pi over 6. The top number of fingers is 3, so the x is root 3 over 2. And then since tangent is the positive trig function in quadrant 3, that implies that the cosine would be negative. So negative root 3 over 2 is going to be our value for 7 pi over 6. All right, let's try another one. I'll switch colors here. So for example 2, we're going to look at tangent of 7 pi over 4. So again, start with a sketch so we have an idea of where we're working with here. So we've got 2 pi over 4 up here, 4 pi over 4 at pi. This would be 6 pi over 4. And we're not there yet. This would be 8 pi over 4. So obviously 7 pi over 4 falls in that fourth quadrant. That's our angle theta. Baby theta, or our reference angle, is going to be pi over 4. Again, we're in quadrant 4, and that means that cosine is positive because that's the calculus quadrant. So we're trying to find tangent. Well, tangent is the fraction y over x, sine over cosine. So we need both parts of that ordered pair. So pi over 4, lucky for us, is root 2 over 2, comma root 2 over 2. So when we build the fraction, I'm not going to write it to save a little bit of space, but we'll build the fraction and we'll get root 2 over 2 over another root 2 over 2. So that's going to be 1. But then we've got to check that sign again. Note here, we saw that cosine was positive and we're finding tangent, so I'm just going to toss that negative out in front. All right, and then let's do one more, and then we'll do some more of this tomorrow. You can try some in the homework, and then we'll pick up where we left off in class tomorrow. Cosine of negative 13 pi over 3. So let's start with a sketch. In this case, negative 13 pi over 3, 13 thirds is pretty big. So I'm going to convert this. So 2 pi would be 6 pi over 3. And then if we double that, thinking about coterminal angles, that would be 12 pi over 3. So if we were rotating in a positive direction, realizing here that this is a negative angle, we would have to do more than 2 revolutions, right? Because 12 pi over 3 is 2 revolutions around. We're going to have to rotate the opposite direction, and we're going to end up 1 pi over 3 past 2 rotations. So I'm going to rotate, and pi over 3 is closer to the y-axis. So I'm going to rotate around twice and end here. So that's theta. Baby theta, or our reference angle, look at that denominator, is just pi over 3. And again, it was that excess where we were at 4 pi, and we added an extra pi over 3 to get to 13 pi over 3. We are, of course, looking at the quadrant there in quadrant 4. So that means that cosine, that's what we were working with, is positive. So our final answer is going to be positive here. And then we're asked to find cosine. So again, we need the x value. So cosine means the x value. And the x value, again, check out pi over 3. In the first quadrant, you should see that that is 1/2. So in this case, that is our answer because it stays positive since cosine is positive in the fourth quadrant. Okay, so give this a try today with the homework, do some practice on it, and bring in any questions you might have, and we'll take a look at this again tomorrow. Good luck.